Hey, and welcome back to the Building Apps for Windows Phone 8.1 Jumpstart. Right now, we're going to jump into talking about adapting our UI for different screens and orientations for our Windows Phone applications. And this actually is going to have some application across not just phones, but kind of bleeding into building UIs that live across multiple devices, phones and tablets. And
yeah, I mean the techniques we're talking about is just the same for Windows Phone as it is for Windows Phone 8.1. So we're going to be talking about fluid design things and techniques for laying out your XAML so it will adapt nicely and flow into different size displays.
Yep. So in this module, we're going to cover adapting that diverse range of screen sizes, different resolutions across a phone, across tablets. We're going to talk about what was the Windows Phone 8 Silverlight approach and how does that compare to what we're going to be doing with Windows XAML and Windows Phone 8. Then we're going to use the emulators to test some of those different screen sizes and resolutions, which is really great unless you want to, hoard about 30 different devices and test what it looks like on every single device. And then finally, we'll get into some of the nitty-gritty details of programming for different screen sizes and different resolutions. So the need for this adaptive UI is driven by the fact that we have an increasingly diverse set of Windows phones.
And it's only going to get more diverse.
And it's only going to get more diverse. I personally use a Nokia 520, which is a nice little 4.0 something inch device, low screen resolution, but it cost me $60. On the other hand, I did not purchase, but was given to by Microsoft, this beautiful 1520, which is it's a monster. It's a huge phone, 6-inch screen size, and 1080p resolution. So
beautiful.
Right. So we've got. I mean, we could fit this one inside of that one if we wanted to. But we've got applications that are going to be running on both of them, so we need to make sure that our applications do, in fact, run on both our smaller phones and our larger phones. In addition to that, they are going to be running on multiple orientations, especially when we're talking about applications that are dealing with photos and videos. The landscape mode is vital for the good application of those, or for good design of those applications. So the applications need to, all of our apps need to cope with this diverse set of display sizes, resolutions, and orientations.
And actually, you tend to use Visual Studio and you'll start it up and this designer is kind of the 4.5 inch and that's what most people are going to kind of end up thinking about, and you kind of get into this, you forget there's actually this diverse range of phones there. So
yeah. So to recap, this was Windows Phone 8 design as of not too long ago. There is essentially an app was designed with one resolution in mind, and the OS applied all the vector scaling for that. And so you would design your phone application with your your sort of standard 4-inch, I think it was 480 by 800 resolution. And then as the phone resolution got bigger, we simply scaled that up. If it got a little longer, we just add a little space down at the bottom. But that meant that we were looking at the same application on a 4-inch device as we were on a 6-inch device.
Yeah, and but it was good for a developer or designer.
Right, it was easier.
It's all the same.
Right,
it was 480 wide. They're all 480 wide.
Right,
800 or 853. So it's easy.
Right, but for the user, what you ended up with was, as you got to the larger size devices, you get an application that started to look a little comically large and like sort of a large print book on your phone. With the latest update of Windows Phone 8, the GDR3 update, we started to get a little bit of a hint of how we could use an expanded size and a larger screen to deliver better content to a user. And so we saw with the 1520 GDR3 update that we had this extra button, an extra row of tiles, so that we gave users with more screen real estate a better option for accessing all of their information, getting as many tiles and as much information on the screen at one time. So.
Yeah, this is a kind of little bit
Right.
of a side topic, isn't it? It's like
Yeah. So the this kind of the standard way to think about any device has been pixels. How many pixels does it have? But when it comes to phones, especially, this can be a little bit misleading. And part of this is because we have different screen sizes that are. We have many of the same screen sizes support different resolutions. So, for example, the Lumia 1320 is a lower end, lower cost device, but it's exactly the same screen size as the 1520. So what we have is a 720p screen versus a 1020p screen that are exactly the same physical size. Now let's say that we had been designing with pixel sizes in mind. Let's say we've got a header, maybe, and we've designed it for the 1320. Well, that makes it 720 pixels wide and maybe 100 pixels at the top. We bring it over to the 1020, now it's squished up at the top, and it doesn't even take up all the space that we have on our phone. And so we have to stop thinking, we developers and designers have to stop thinking about, oh, well, pixel size equals this size, because we're looking at different DPI and different pixel size for the same screen size. Similarly, we have the idea of the raw device pixels. I'm sorry, another way we can that raw device pixels doesn't quite work is because we do have these super high DPI devices, the 1020p on a 6-inch device. Well, that's going to have a lot more pixels than an 8-inch device like the Dell Venue 8 Pro, which is...
So the real true dots per inch on that 1520 is like really high dots per inch.
Right.
The physically much bigger tablet has much less pixel density on it of true real pixels.
Exactly, but that doesn't mean. But we still wouldn't want a 6-inch display style moving over to an 8-inch display device. They're different devices with different sizes, and we're going to be using them differently. And so So what we need to deal with is, okay, we need to reuse pieces of the UI across platforms, and we need an abstraction that works for those high-resolution devices and smaller screens, and lower resolution devices with larger screens.
It's like you want to be able to cut and paste a block of XAML from one app and stick it onto an app that's going to run on a huge wall display or something,
Right.
and it will look right.
Right. So it's actually a big design question, and we're going to explain how we've designed the Windows XAML to kind of tackle that problem. And that's the Windows Phone 8.1 approach. How do we...
Well, although actually it's the Windows 8.1 approach, isn't it? Because it's obviously
Right.
the same one that's used for tablet and PC.
Yep, and
store apps.
this is one of those universal concepts that now spans from phone to large phone to tablet to wall-sized devices. No longer do we have a set of devices. Instead, we have a screen of unknown size. It is upper bounds of X, Y, and it varies depending on the device. The maximum values of the X, Y are dependent on the device in question, and the display resolution of that device. So we've got this sort of infinite virtual canvas on which we are laying out all of our XAML elements. So we've got this thing called scale factor. And each device is going to have a scale factor, and that's calculated by taking how many actual pixels are on the device, dividing that by the physical width of the device, and then multiplying that by a platform constant. That scale factor is not going to be any smaller than 1, and it's going to get rounded up to the nearest 0.2. And the platform constant depends on the viewing distance of the device. Now, well, what does that mean? Okay, well, I've got a phone here, a small phone or a big phone. I'm probably holding it about 18 inches from my eyes. That makes the physical size of the device actually not as important as how I perceive the size at 18 inches from my face. I have a Surface tablet here. It's a 10-inch device, but I'm going to hold it a little bit further away, maybe 2 feet, maybe 30 inches away from my face. And then behind us, we have a big screen. I'm going to guess maybe about 36, 40-inch screen there. But I'm never going to be standing 2 feet away from the screen and looking at it. I'm always going to be further away. And so the platform constant is a device-by-device constant that helps give us the appropriate scale factor depending on how far away from that specific device
typical usage of it.
we're going to be using it. Yeah.
Yeah.
So so we take the raw pixels that we have on the device, we divide it by that scale factor that we're given, and then we get the real key, which is the view pixels on that device. And all of our design is going to be done inside with this concept of view pixels in mind.
Yeah. You don't have to do any of this calculation yourself, just in case.
Right.
This is for interest, so you can figure out how it's working.
Right.
Yeah, but the view pixels actually gives you a reasonable XY coordinate layout system that works and
Right.
will work for the device, any device.
Right. And the goal here is to kind of abstract all of this work away from a developer. Don't worry about the resolution of your device. Don't worry which device it's on or how far away it is. All you need to worry about is this view pixel rendering, because all of the pixel information that you give your UI is going to be translated into this view pixel information. So this helps us when we're dealing with images that are the same size but higher resolution. So we could have a lower resolution 5.5-inch device or a super high resolution 5.5-inch device. That doesn't matter. It's a 5.5-inch device. It is 800 by 450 view pixels.
Yep.
Similarly, we could have the same resolution on larger size devices. We could have a super high DPI 1080p screen that's only 4.7 inches. Well, it's actually going to be smaller view pixels, because just because it's higher DPI doesn't mean you're holding it closer to your face. The larger screens get more view pixels because from a user perspective, it's a bigger size.
I think, for me, to summarize this, the view pixels you end up working with, it's just based on ends up being based on the physical size of the device.
Right.
And whether it's a phone or a tablet or a
Right.
TV, So,
Yeah.
But
Yeah.
it gives you the right outcome for doing design that's just going to work based on the physical size of the device.
Yeah, there's a little bit of secret sauce in there, but ultimately the goal is we're giving you the right pixel size for the usage scenario: phone, tablet, large screen. So when we're working with this practically, the emulator is going to be our best friend. We felt this is so important that we've actually designed emulators not just with resolution sizes, but we've also imprinted these physical sizes onto all the emulators. So you can see that you can run specifically a 4-inch emulator, or you can run specifically a 6-inch emulator, and so you can do your design and do your testing on these different screen sizes.
And not only that, but different physically sized emulators at different screen resolutions.
Right.
Yeah.
Right.
So you've got the whole works there.
So how does the right app how does an app provide that right UI experience on a given device? First of all, we need to make sure that our bitmap images are working with the scaling system. We want to make sure that we have the right high resolution content for the right high resolution devices. We need to build a responsive UI that adapts to that usable screen size. We want a UI that's going to give more space where it has more space, and is going to maybe even hide elements where there's not enough room to show them. And then last, when we're doing our real fine-tuning work, we can make use of the display information class for that granular display info. We can actually go in and we can query what's my raw pixels look like, and what are the view pixels that we have on this particular device.
Fairly few cases where you're going to want to do that.
Right, exactly. This is that's something where maybe we're looking to download some web images and we can't rely on the responsive image system that we have built into the application. In that case, then maybe display information will help give us more a better idea of how to respond. So let's start with getting those just the right bitmaps that we need for our low DPI and high DPI phones. Because bitmaps only scale so far, right? You have a 100 by 100 bitmap, and if you scale it up to 300 by 300 or 400 by 400, it's just going to start to look kind of bad. And so we have a system for resolving resources. If we set the image to a particular source, the system attempts to find that image name along with a scale dash number. And the value of that number is based on the scale factor that we were talking about earlier. If it doesn't find an exact match, it's going to fall back to the next best scale factor. So let's see what this looks like in a little bit of a conceptual example. We have our image, we've set our source. It's loaded onto a phone where the scale factor is 3.2, which is actually really high DPI, probably. The system has defined the scale factor buckets. And so there's a scale factor at 100 and 120 and 140, 200, 300, 400. This scale factor of 3.2 falls into one of these buckets, right in there between 300 and 400. We're going to round up and pick the 400 element, and that high resolution image is the one that we're going to bring in. We're going to place wherever that image control has gone. So if you're a designer or you're a developer and you're creating these images, you need to make, there are two kinds of images you're going to create. The first is the variable size image, something that you're going to put in the background, for example, in that pivot application, or the hub application that we saw in the last session. That's going to resize to fit the full screen of the device, and so we need to design it for a high resolution image, or high resolution display. When it's on a low resolution display, don't worry, the system will take that, it'll resize it, it'll put it in just the way it needs to be. When we're looking at fixed size images, we want to start by designing it for a 140 scale device or a 1.4 scale device. If we open up our design area and we size at 100% to get our baseline width and height, we can take that number, in this case 100 pixels by 100 pixels, and we can scale it up to other images. So two image sizes we want to keep in mind are the 140 scale and then the 240 scale. That's the baseline. That's the absolute essentials that you need. Although if you want the best experience for the most devices, then try to scale it up at a number of those gradations.
Yeah. But at the very least, you want to just try and supply a whole set of high-res 240 scale images, and they'll be scaled down just fine for the lower ones, but obviously at a slight cost of resources. But, yeah.
So let's take a look at what that means in some sort of practical application. This is actually very cool because it shows off the tools that we have and how powerful they are for doing things like managing these different resolutions. This is a really complicated application. It is a grid with another grid and an image inside. And the image is set to this resolution.png. And if we open up our images, you see we have these different folders. Scale 1, scale -100, scale -140, -180. If we hover over those, we can see these are actually different images that give us an idea of what's going on. So they have the scale imprinted on them so that when we load them into our device, we can actually see what scale we're working with. I could load up multiple emulators and cripple my system, or I'm actually going to use the device tab over here. And you see what we're looking at right now is a 480 by 800 display type. We can change that to it's not quite 720. But a higher resolution. And you see, it's pulled. We are looking at the exact same image source, but because it's a higher resolution, the system goes. It knows which image to find. It finds that image. It pulls it back.
But the real clever thing about this is in the XAML, you don't have to specifically load in that image. You just leave the scale bit out of the path and it works it out and it will go and find it. As long as you use this convention for naming of the folder path.
Exactly.
And there's another way you can do it just by embedding it in the name as well. So, but either way, the system will just pick the right one for you. And you don't have to actually specifically write any code to say, oh, what resolution are we on? Go and load this one. Oh, no, we're on the different one. Go and load this one. So,
And the other one, and it can be a little bit hard to show sometimes on the emulator because the emulator is has a percentage here. But if we go to 180, let's go to 180 here. You can see that the image has been resized according to the size of the emulator that we're using. So we've got So we've got an image that's resizing appropriately, exactly for the size of the emulator. It's going to size appropriately when we pull it on a larger screen, on a smaller screen, and that's all being handled simply by placing the right size, the right resolution images inside of this image resolution folder tree. So that's image scaling. Now let's look at responsive UI. How does our UI respond to these different resolutions, these different sizes of device? Well, it starts out with what we were talking about earlier, where the page is set up to make sure that whatever content you feed it will size itself to the space that we've got available to it. So the actual content area where we display our content is automatically adjusted to lie between the bottom of the status bar and the top of the app bar, and those bits of UI are visible. The page gives all that space to content, and your root content panel will fill all that space. So what are the factors that affect the XAML sizing? This is an example of kind of something you don't really want to do. Here we have explicitly set pretty much every element here. We've said that our margin is 6. It will always be 6. On a small device it's 6, on a huge device it's 6. The padding is always 12. The height is always 96. And so if we do that, this is not a very flexible XAML design, and it's not going to look good on every single device. Instead, we can do something, and this is where the grid layout really comes out to shine. Because the grid layout gives us this really fantastic way of doing proportional layouts with a couple of different ways of sizing things that work really well for responsive design. The first one is the star sizing, which I'm going to show before I jump into the other ones. Star sizing is proportional. And so if we have 1 star and 3 star, we add those two together, we get 4. So we get 1/4 and 3/4, 25% and 75% of whatever space is available. Auto sizing looks at the content that is inside of the grid row or column and says, I will give the items in there however much space they need to render. And then the proportional will split up the rest of the space however it can. We can give those auto spaces min or max widths and limits to their height. So we can say, for example, let's say we've got some text in there, and we put text into an auto row. Well, we can say, I don't want that to be any bigger than 100 pixels. At 100 pixels, you should stop giving it all the space it needs, and then let the proportional sizing, the star sizing, take over the rest of the space. The last one we can use is pixel sizing, which is a hard-coded size, which is something mentioned just before. Is we're going to want to avoid that in most cases because it's gonna look a little bit different on. It's less flexible and it's just going to look different on our different devices. So here's a nice simple example that I think shows how grid allows us to do this great proportional layout. We've got a header. We've got a bulk items control, and then we've got a footer, so to speak. The header's in an auto area, in an auto portion of the grid. The footer's in an auto portion of the grid, and all the rest of the space belongs to this items control.
1 star, so we just get whatever is left. Yeah. Yeah,
whatever is left over belongs to that items control. So on our lower sized device, we can see that we have our 2.5 over and 3 down. That's all. Those are all the items we could fit in that space. But then we go to a larger size device and we get a lot more of those view pixels. And so in this case, we're actually looking at the items have been specifically sized. They're maybe 100 by 100 or 200. Maybe 100 by 100. That looks about right. But the header is still taking up the automatic space that it had available. The footer is taking up the automatic space it had available. We get more items in the space, both horizontally and vertically. So what should we put into that sort of additional space that we get with the proportional sizing? Well, there are a couple of really great things to put in there. The first one is, as we saw in the example before, the items control is a great thing to stick in there because then we can show more items on larger screens. The second one is text blocks and rich text blocks. So if we have a certain amount of text and we ended up having to cut that off because we just didn't have enough space on a 4-inch device, well, now we have a 6-inch device and we can show more of that text. We can give the person, the device with more space, more information. Anything that's going into a content or into a scroll viewer, when we put it into a smaller device, it's still visible with scrolling. A larger device, we can see more of it. We don't have to scroll as much. And then more complex controls like the map. When we put it in there, it'll resize to whatever space it can manage to get, and then it'll handle the rest of that resizing itself because it's awesome. The other option is if we don't want to try to do all that work, we can just scale the content as it's designed on one platform and put it in a viewbox control. So looking at some of the additional space content in a practical XAML, here we have some text in a lower sized device. You can see we've got the text wrapping, we've got some word ellipses, so whenever that text runs out of space, and in this case it has 20% of the screen space. Whenever that text runs out of space, it's just going to go to the ellipsis. On a larger screen, 20% of space means substantially more room for that text. We see we have more room to fit the text across the screen. We fit more words across the screen, and then we get an additional line stacking on top of the stacking in the text. If we want to put hard limits on that, we can always use something like max lines on our text blocks in order to say, 6 lines is enough for this piece of text. After that, we just don't need any more. Showing off the view box, this is an example. Let's say this is a control in there. This watch could be a vector graphic, or it could be a really complex XAML control that we've styled very carefully. And we realize that when we pull this XAML control into our Windows Phone application and we resize it, things get all wonky. Well, we can drop that inside the view box. The view box will render it in one size. And when we go to a bigger screen size, it will simply scale that entire control all the way up so that it looks better. Which
actually is what Windows Phone 8 did on all the devices. Effectively,
exactly.
Logically a view box,
right.
Which is how it got that kind of single layout sizing system that kind of worked.
Right, and so this is actually kind of neat because we can do this, but just on a case-by-case basis. Yeah. We can say, I want this control to render, to just simply size it up or down depending on how much space we have in the device. So, looking at the responsive UI in a demo form, let me pull up this responsive UI and I'm going to look at the... So here we have a view box holding this text. So this text will always take up, it will always be this big. The text will size to that area, and the view box will make sure that it resizes appropriately. It's sitting inside of a grid that has, let's see if I can, the row definition, so 25% of the space up here at the top in the single star, and then 75% of the space in the bottom in the 3-star goes to this number grid that we have in place. So let's run this and see what this looks like. You see, so we've got that text up at the top, and we see that we have 4 items across, and then it scrolls down. We can change that by rotating, and now it looks like the text got bigger, and it did get bigger because now it has more space. It has more of the horizontal space it needs because it still has 25% of the space of the view that we have it in. You see, we have more of the items because they have not simply resized. They now have more space to make their layout. And so we lay out more across the side and fewer down because we have less vertical space.
The rotate animations come for free.
They do, and
Yeah.
it's amazing.
Yeah.
So when we're responding to those rotation changes, we want to display dimensions that can change at runtime. We use that using the display information.get for current view, and then we just listen for the orientation changed event. And when it does that, we can handle that orientation change. This means that we can actually run what we saw before with the text and the items control. That was actually just the grid view, the grid panel being awesome, right? The grid panel and the view box working together to give us this great layout. Instead, but we can actually run code and change our actual layout if we use this orientation change, and that way we can change things like visual states. We can have one visual state that manages our screen when it's in portrait mode, and another visual state that manages the screen when it's in landscape mode. You see, in this example, what we have is an image inside of an auto grid and a text block inside of an auto grid, and we have a grid that is set up so that it works with both systems. It's a 2 across, 3 down, and we simply change the grid.row and the grid.column properties of our rich text block to move it from one place to another, depending on which orientation we're in. So we're going to look at the orientation changes. And this one we're going to just open up the emulator, take a look at it, and then see how we've done that in the XAML. And here we have a single image, and if we rotate, we see we get kind of a much different layout. We still have the image there, but we've added a group of text on the orientation change. Okay, there we go.
Crazy.
We're going nuts. So the way we've done that is we have these visual state managers here. There is no way, I just can't see this. We have these visual state managers, one for portrait and one for landscape. And when they come into play, we are changing the size of our image. We're changing the size of our image, and I think we're changing the visibility of our text, text information. And so if we go down, this is really big and I don't have a lot of space here. If we go down here, we can see that our text block, our image, we have our image, we have our text blocks here, and we are just going to hit those, we're going to change those visual states. The way we do that, as you saw in the slide deck, is we have that display information and we're listening for that info orientation change, that orientation changed event handler. And then when it hits, all we have to do is the visual state manager that we've defined. We say go to this one, go to landscape, go to portrait, and then it resets the properties on those elements, and we can go ahead and see them.
So you can hide elements. You can
hide elements.
Move elements from one cell to another in the grid.
Any property that we have on the element, we can change using our visual state manager. And so the last piece is for those edge cases where we really do need to know pixel information about the devices that we're on. The display information class gives us a lot of information. It gives us what our native orientation is, our current orientation. We can look at the raw pixels per view pixel, and this will give us the scale value. This is this is basically undoing the division that we saw earlier when we were taking. We are translating raw views into view pixels. This translates view pixels into raw pixels. We can use raw DPI X or raw DPI Y. There's not a whole lot of scenarios in which this makes a lot of sense, except for real object scenarios. And so we could take the raw DPI, do a little bit of math, and say, oh, well, you're looking for a 9-penny nail or a particular screw, and you could actually take a size on your device and say, I want an inch. Show me what an inch looks like on this device. The last one we have here is logical DPI. And the logical DPI is something we're going to want to avoid unless we're working in something like Direct 2D that assumes the max DPI available is 96. And so it's something we just generally are going to want to avoid using. And back over to the demo. This demo is really very, very simple. It simply grabs all that information from the display information class and pushes it into our into some text that we have in our XAML. And so if we run that, we can run it on different devices, we can run it on different emulators, and we're going to see the specific information for that specific device show up here. So to summarize, all of this information about adaptive UI really is a great deal of information, but it's important because we're now looking at an adaptive UI system that is shared between Windows and Windows Phone. This is beyond just uniform scaling of the UI. It's all about building a UI that just works for the device that we're on, for the orientation that we're in. We need to make sure that our display size of the runtime device, even though the display size is unknown at design time. The apps, this allows our apps to be responsive like they need to be. Our design for proportional layouts and not fixed sizes means that we can build applications that just fit all the devices orientations that we have in place. We can test this on different devices or, more helpfully, inside of our emulators. And we should consider using the techniques such as the Visual State Manager to handle all these changes and these different device sizes. Finally, that raw display information is available for those apps that need it, but we recommend to designers and developers to apply these adaptive UI techniques and make sure that you're not fussing over or worrying about the raw DPI or the raw pixels that you have available. So
good.
We'll be back in just a little bit.
Yeah, we'll take a few minutes, and then we're going to look at the life cycle and following that localization.
Woo.
Hi, welcome back. So, from one meaty topic to a trivial thing that's just going to take no explaining at all. So, no, another meaty topic, which is the Windows Runtime app lifecycle. So, we're going to look at how apps behave and how they get suspended, how they get killed, but more importantly, what you have to do as an app developer in order to handle this kind of thing. So, there's a lot that the framework does for you, but it kind of imposes certain behaviors on your apps that you have to be aware of, and you have to write some code to save state and restore state when it's appropriate. So we're going to start, well, this topic is going to talk about launch, suspend, resume and termination, and saving and restoring state. Nice and sweet, but actually there's a lot to talk about.
Yeah.
So why do we have a life cycle at all? And actually this is true for Windows 8 store apps as well. So battery is the most precious resource we have. In terms of user experience, you know, nobody loves a phone that runs down in no time. And if they think your app is a battery hog, in actual fact, and they can find out now because there's a battery saver app which will tell them exactly who the hungry apps are. So if your app is a battery hog, you're going to end up with some bad feedback, and people are going to uninstall your app. So the way the OS helps to conserve the battery is that it makes sure that it'll only run one foreground app at a time. First session tomorrow is about background execution. So you can run code in the background under certain controlled circumstances, but there's no UI with anything that runs in the background. So when we talk about a foreground app, we're talking about an app with UI, and there's only one of them at any one time can have the screen. And if the user switches from one app to another, the ones that have been that are no longer in use, they get suspended. And in periods later on, if the phone is getting short of memory, they might get terminated. So we've got many mechanisms. The framework gives you some mechanisms for helping an app to have this illusion that while it's been suspended, it's been running all the time in the background. But you have to buy into this and work with those mechanisms. This is very similar to the way Windows 8.1 store apps work. But there are a few differences due to the just because of the more constrained nature of phone hardware, and also some things that are about backwards compat with older apps. But it is very different from the way the Silverlight app behaves in the Silverlight app lifecycle. So this will be, if you're moving from Silverlight or interested in developing for Windows RT XAML, you will find this a little bit different. Okay, so the first concepts: launch, suspend, and resume. All pretty simple, I'm sure, to most of you. So here we go. The user launches an app. So they tap on a tile, perhaps, and we're going to use the calculator as an example here. They launch the app, and the app is running, and the user interacts with it, and life is good, and the app has full access to the CPU and the memory and everything, and it's a happy little calculator. Now, there is a method in your app.xaml, which in all the templates you'll have this in already in your app.xaml.cs.vb.cpp, which is the onLaunched method, which this is where you can find out, well, you can run some code of when the app is launching for the first kind, and you can also figure out what kind of activation. So you get this in the args, you get this previous execution state, so you can figure out what happened before this launch. What was what happened to it, the last thing in its life. And you can see you've got these 5 options. Not running at all, so the app's maybe just been installed, never run. It was running, it's been suspended, or it was terminated, or it was closed by user. We'll talk about what each of those mean as we go on. You can also find, why has this been launched? Actually, there's a myriad number of ways an app can be launched. I mean, we showed tapping on a tile there, or you can go to the Programs menu and tap on the listing in the Programs menu, those are just launch ones. But you can actually also have an app launched by file. That means we use app-to-app communication, and somebody has sent you a file, and your app has been registered as a file handler for that particular type of file. We talk about that tomorrow when we talk about, what are we talking about? Well, file and protocol.
File open picker.
Yeah, that's right, and the file and open pickers, and the file and URI associations. So that's a file. Protocol is a URI, similar thing. So somebody's launched a URI and your app is registered to handle that URI. And you can voice commands. You could be launched by Cortana. So that's another way. And there's various others as well. So you get a lot of information on launch about why you started up. Now, what happens when your user navigates away from your app? So they've been using the calculator, and then they hit one of these buttons, or you get a phone call. So if they obviously hit the Windows key, that will take them back to the start screen. That's the classical way of going away from an app. Or back, as we saw when we were looking at the back key handling, that would take you out of the app if you're on the launch page. And then the right-hand button takes you either into the search experience, which is Cortana if you've got it, or Bing search if you haven't. So what happens when you get suspended? Well, actually all your code is stopped, suspended where it is. All timers stop running. No more events. It is totally suspended. The system will take a snapshot. It sort of puts you into suspended animation. It'll take a snapshot of your working set, your memory. Effectively, that process is still alive. It's just not running. It's not ticking over or any time. But just at the point it gets suspended, you do have a chance to run some code. And that is in this on suspending on event handler. So again, all of the new project templates will have this already wired in, and it will have some template code in this, which is what you're looking at here. And in on suspending, you want to do whatever you need to do when your app suspends, and we'll talk what it is you need to do in a moment. But actually what it will be is about saving data, for example. You might want to save some data away into persistent storage, into files or into a database or something like that. And if you're doing any async methods in there, you need to use this deferral. This deferral is a nice way of allowing you to do async calls within an event handler, but kind of deferring the continuation of the OS as it's trying to suspend your app. You're kind of saying to it, when you take a deferral, you'll say, well, okay, I'm just going to do some async methods here, so just hang on there. So when you're finished, you then call deferral.complete, and that signals back to the caller that actually this on suspending processing has completed. So You only have a limited time to do all this, so you need to think about this. Don't defer all your work into this on-suspending event handler. Typically, in a mobile app, you'll save files as you go along. You know, as you leave a page, you might save data and that sort of thing. But you only have a limited amount of time in there. This is that deferral thing. If you're doing any async, you get the deferral there and then call it later on. Okay, so now what happens when the user comes back to your app? So there's a number of different ways it can be relaunched. So the left-hand one is actually the user could go to the start screen and tap the tile again, which would cause the app to be reactivated. Silverlight app developers will notice one change there. We're getting reactivated, not a new instance launched. The middle one there is where you're on you've gone to another app. Here we've gone to the Microsoft.com website, and then you hit the back key from that website, and that's going to take you back to the previous app, which takes you back to the calculator. And the other one is if the user taps and holds on the back key, you get this task switcher comes up where you get these thumbnails of all the apps that you've been running, and you can swipe across to any of them and tap on them to reactivate it. So then as soon as you restart, your code picks up just where it left off. Just starts running all its code and your timers it comes out of that suspended animation and away you go. You can run some code on that instance. Actually, you don't so often need to do some stuff on this, but this isn't wired into the template. So if you want to run code on resuming, you need to add that this.resuming plus equals on resuming into your app constructor, wire up the event handler, and then you will create that event handler and you can put your code in there. Now, just to be careful, the debugger both is and isn't your friend in this sort of thing. So by design, so that you can debug all these sort of things, when you actually do one of those things through the phone, which on a real app would normally suspend it, like hitting the Windows button, the key, or or search or something like that, or launching another app, then actually your code will still keep running under the control of the Visual Studio Debug. It doesn't get suspended, but because you obviously need to test these sort of things, we've actually got this special drop-down in the toolbar there, which allows you to suspend from Visual Studio. So this will trip a number of people up, especially if you're coming from Silverlight, because in Silverlight, when you move away from the app in all of the ways we saw on the previous slide, then your app will actually get suspended. Not true with Windows Runtime apps. What do you want to do on resuming? Well, you have to think about what's the effect of having this pause in your operation. So you might need to check on any external things that you were checking. You might need to call a web service to check that some status has changed or something while your app was suspended. You might need to think if you've got any time-dependent processing. So many apps, it won't matter. If it's a calculator, it just comes up and it's just the same as it was when you left it. But other apps, if you've got some processing there that is time-dependent, then you need to figure out how long you were suspended and adjust timers and do whatever it is you need to do to compensate for the fact that you've not been running for that period of time. There's plenty of other examples. There's a good link there which you can go and have a read of. Refreshing data from an online source. Check. You might have switched the phone might have gone offline while you're suspended. So if you're a networking app, you might want to change your status when you come back. Sensor data, you might want to go and get some new readings. Networking call, if you've made an HTTP request just before you're suspended, when you come back, actually what will happen is that request will complete with an exception because the call will have been dropped while you were suspended. So you might need to make that call again. The phone could have been changed from portrait to landscape, so you might want to do some of that Visual State Manager stuff or something like that. Or go off and get new data that background tasks might have fetched for you, so or from roaming data, which we're going to talk about in the very next module. The app can be closed by the user. In the task switcher, when they tap and hold on the back key, and you get the thumbnails up, they just tap on that thumbnail, it relaunches the app. But if they tap on the X, you can actually close the app. So this is for Android fans. This is for you. So this is there's been a lot of in the first versions of Windows Phone there was no way to close an app. but you don't need to because they're suspended. But anyway, people like to feel in control. We get that. So if you really want to close an app, you can through the task switcher. That is where the close by user status comes from. There's no other way that the back button doesn't close an app. Which, again, with Silverlight, if you do a back button from the home screen, that terminates the app. Not true with Windows Runtime apps. So I've got a little bit of a demo to show all that stuff, which I will show you now. Not that one. Here we go. So, oh my gosh, just sign again. Okay, so this little app, very simple. Let's just run it first. You'll be pleased to see these are very simple apps. Here we go. This is count. You can see there's just a counter running, and it's just putting the count onto the screen. And if you go away from the app at about 10 seconds, and then we wait for like, you know, a few seconds, and then we go back to it, what you would expect is it still said 20. It should still say 10 seconds, but it doesn't. It says 22, and this illustrates that fact that it's still been running in the background while it should have been suspended because we're under the control of Visual Studio. If we stop Visual Studio and then go and run that app, which is called App 1, imaginatively, and we suspend it at 2.2 seconds, and then we wait a few seconds, and then we come back to it. So this is a proper suspend because we run it from the phone. It's going to come back at 2.2 seconds. So, you know, that illustrates what we were talking about. And if I go tap and hold, I can close it by user. There we go, it's killed it. Now, what if we want that timer to survive? We want the timer to resume with the timer in the right place. So we want it to handle being suspended like that. And when it resumes, to reset the counter so that we know we can sort that out. We can do that very easily. So that's the version that we've just been running, which didn't have any resume handling on it. But now what I'm going to do is simply hash define this an if-def called add handlers, which is going to add in some other code. So now we've added in this .suspending event handler and on resuming event handler. So now in our on suspending, we set a property, this .suspension time. This .suspension time is just a property on this, go to definition, on this class. There it is at the top, suspension time. And so we're going to save in the state the time. And then in our on resuming, we find out what the current time is, subtract the time we were suspended, and then we can reset our timer, the elapsed milliseconds. So we actually, our data value, which is what the clock is showing, we add on that elapsed numbers of seconds. And when we resume, it will pick up all right. So let's just run it in there. And I'm going to, there we go, we're going to let it run, and I'm going to go up to Lifecycle events up here. I'm going to, at roughly 5 seconds, I'm going to suspend it. And it's suspended. And then we've gone about another 5 or 10 seconds, and we're going to resume it. And it's picked up where it was. So we've got the right behavior that we expected from this app. Nice and simple, just using on suspending and on resuming. Right, what about termination? What is termination? So that was a suspend, and not all the time it was suspended, it was just, the process was still alive, it just was suspended. But the OS can terminate your app. So if the user runs a different app, and at this point, and this is kind of more likely on like your 520 there, which is a low memory device, 512 megs memory device. Whenever we suspend, obviously the device memory is being used to hold the memory of any suspended app. So at some point, we're going to run out of that cache. So there's not going to be enough memory. If we got a number of suspended apps, and it can, you can keep on suspending, and you can have loads of these things. At some point, it's going to need to get some memory back in order to suspend the latest one that you just decided to suspend. So the OS will terminate an app, one of them. It just blows it away. So it will destroy that saved snapshot of the memory. It closes down that process, and it's gone. And the system figures out which one to end, which one to destroy. It's not necessarily the completely oldest one, but it will be one that allows it to get the memory it needs to save the one that it needs to. You don't get any notification in the app. There's no event that fires when this happens. The app gets removed from the task switcher list, but it's gone. So the implication for this is that actually on suspend, you need to think as a developer, actually, that you don't know that you're just going to be resumed from a suspend state. You could actually get terminated. So if the user returns to a terminated app, so that they tap on the tile and restart the app, again using the calculator, what you need to kind of bear in mind is that as a developer, you want to try and maintain the illusion that the app has never been away. You need to make the user think that it's been suspended, even though actually it's been terminated and it's actually been blown away completely and destroyed. So that means you have to write some code to save some data away. You need to maintain that illusion. So you must make sure that the user doesn't lose any data, and actually that their experience is not spoiled by this as well. So there's a lot of things that go into that in what you need to do. You might need to restore what we call transient session state, and you obviously need to make sure you save page navigation history. So when they come back, if they were on page 3 of a multi-page app, when it comes back from terminated, you want to make sure that it starts back on page 3 in most cases. And in fact, if they half filled in some data into fields on page 3, you probably want to make sure that data is still there and visible to them. So this is where you as the developer really need to get involved with this. What do we mean by transient data and persistent data? So if you think about a telephone list, the list of contacts there with telephone numbers, that is the permanent data, the persistent data of the app. This is what the app saves away into a file or a database, and you run it much later on, or you will get all that data back up. This is the permanent persistent data, and you'll save this persistent data, you'll save that away into, and you add a new one. And you're adding a new contact onto this with a mobile phone number and a phone number. You choose some contacts, some details like this. And at some point, that data, as the user goes through it and has hit the save button, is getting saved away into a file in your local folder, into files. And we're going to get onto files in the next session. Stores it away into a persistent file. But if they're halfway through filling in that data, so we're on the third screen there, and they're halfway through entering a phone number, but they haven't hit save yet, that's stuff that is transient. It's just stuff that they're halfway through doing. It's unfinished business. That's your transient state data. And that's what you want to think about saving on a page if you want to put them back to exactly the same state that they were in when they left it, when the app was suspended. So if in the meantime it's terminated and blown away, and then later on you restore from a terminated, you need to restore the values of those fields into those fields when it resumes again. Lot to think about. So another demo to show all that. Oh, there we go. Which is also called Imaginatively App 1. And it's a similar pattern to the other one. So we've got some handlers up there. So first of all, we'll run it. And what do you know? It's a timer again. Now, if you look very closely at the bottom, which might be difficult if you're a remote viewer of this, but it actually says at the bottom, it says app previously. So this is the previous state. It wasn't running. So this is a whole new app. And the app has been running for 13.8 seconds. So I'm now going to suspend and shut down. So this is simulating a termination. So we're going to suspend and actually destroy it. So the app has gone completely. And now the user is going to restart it again. And we were on about, I don't know, 25 seconds or something. And you want it to come back from a terminated state. But it started all over again. So we've not saved the transients. We've not shown saved any of the state of that. Now, and also we see if we look at the bottom there, it says at previous state was terminated. So it was terminated by the OS. Now, if I hash define this, we're going to add in some of the right kind of behaviors. So now in the save load state, if it's terminated, we're going to, on launched, we're going to load our state from a file. We get our data value back from a file. And I'm sure you won't be surprised to see that in our on suspending, we're going to do some async work. So we've got our deferral either side of it. And we're going to save our state. So we save the value of the counter away into the local file. And so now when it resumes from terminated, it's going to pick up exactly where it left off. So we can demonstrate that now. So here we go. We're running, and we're going to go up to about, I don't know, be about 5 seconds by the time I've done this. There we go. It's terminated. It's not running. Run it again. And now that logic's kicking in, and it's picked up exactly where we were. So we've now got, by saving that state away into files, we're now surviving termination. Now this is a super trivial example, but it gives you an idea of the issues that you have to grapple with here. Right. Now then, well, I kind of touched on a few things there, which is like not only that pages need to save values of controls where the user is kind of half finished entering some data. And I also touched on this idea of having a multi-page app, and the user needs to, if they're on page 3, they need to go back to page 3. This is all state that is lost. So the frame, if you remember, manages pages, and it also keeps a record of the navigation history. I told you that a few sessions ago. So that has the ability to, you can get out of the frame its navigation history. It actually has a property on there which returns to you as a string its navigation history. So you can get stuff out of the frame about its navigation history. You can get your permanent data and save it into files. And you can also save on the page transient data such as half-completed unfinished business. And all of these things are ingredients into bringing your user back from a terminated state into where they need to be. Now, there are two classes that are given to you in the more complex project templates, which aren't in the blank template. The navigation helper, which we've already seen, which has the back key handling, but actually that's only one little part of a bigger story. So the navigation helper works actually with another class called suspension manager, sorry. And these two work together to handle all of those different things I was just talking about. So this is run through how it works. For a clean new launch of the app, the app fires the on-launched event, the frame gets created, we saw all this, and then in your frame in the on-launched method, you need to register that frame with the suspension manager. There's a method you call in the suspension manager to register the frame, and that ties the suspension manager in and allows it to get and set the navigation history on a resume from termination, and it keeps aware of that as the frame is navigating. The suspension manager is responsible on suspension, saving all that data away into permanent storage. Now, as the app navigates to different pages, that navigation helper comes into things as well. We already saw how it helps us with the back key handling, but the other thing it does is it's helping to store a lot of other data. So the frame tracks the navigation history, including the parameters. And actually, this is one interesting thing about those parameters, those objects that you pass in navigation. That has to be serializable, because this is all going to get serialized, and we'll talk about serializers in the next module. It's serializable so you can turn any in-memory objects into into data that can be saved. And so when you get into a page, the navigation helper calls a method called load state, and in there you can put some logic to load the state back into the page on a resume from termination. And as the page A navigates onto page B, as you leave a page, the navigation helper has a method called save state in the page, which is where you can save that page state. So not only as you're navigating away, but actually the key thing here is when you're being suspended while you're on that page. That is where you're going to save state into that as well. So you save all state necessary to reconstruct the page, as you might get terminated. And you get to another page and this thing goes on and on. You have a load state, save state methods. And when you go back from page B to page A, again, save state as you leave a page. You go into page A to the navigation helper. And on page A, you load your state again. So all this pattern is going on. And this is also where the page cache mode that we talked about before. These are where the load state and save state is where you can reset the state for a page, regardless of whether it's been cached or not. When you go forward, you save state into page B, and then you load state. You can look here, when you're going forward into a page, you look in the load state, there's a clue whether this is a forward navigation to the page. In that method, in load state, you look at the state dictionary that's passed in. If it's null, you know this is a new forward navigation into that page, so you can reset your controls, even if you've got a cache mode required. If there is a state dictionary, then you can restore it. And finally, as the app suspends, in the suspending event, you will call the suspension manager save async method, and that saves everything. It saves the global state, which is the page navigation history, and also the frame state away into persistent storage. Now, there's one thing about restoring state when you come back in is that there are circumstances where you might not want to do that. So maybe you've been suspended for a very long time, a couple of weeks since the last time the user used your app. There would be no point in putting them back onto page 3 of the app and exactly where they were with controls half filled in if they hadn't used it for 3 weeks. They wouldn't remember what they were doing. So in that case, you probably want to do just not restore the state, not get the suspension manager to restore state, and instead start from a new state situation. Okay, so a demo to show all of that. So demo 3. Right, so this one, we've got pictures of some young women, and you can go into one of them and you can click or select one, and here we're in on navigated to. On that page, we've navigated to a page where we're going to save some data. So we're looking at the view model for the data for this. We're getting the data. We've navigated in. We get the data for this particular page, and we're going to get the data from our back-end storage, from our model for this, and create a view model and set the page context. So we've got an object that we are tied to. Hang on, I'm going to talk through this. Let's just run this through. We've got an object on, and now we can go in and edit, which is like we can start changing the data for this. And this is where we can start putting in I don't know, a name. And we this is like an example of the transient state. So we are going to I'm going to terminate this, suspend and shut down, and then reload it, relaunch it again. And we're back to the home page, which is not where we wanted to be. We expected to be relaunched back at the where we were halfway through doing that editing operation. So how can we fix that? Well, you won't be surprised to know there's yet another of these amazing hash defines. This allows us to use the suspension manager. So this is how the suspension manager is tied into this sort of thing. So that hash define has added in this bit of code here, where this is all. This is part of the plumbing. Suspension manager register frame. We need to register our frame in our onLaunched. Here we go, we're in our on launch. This is part of the plumbing that you need to use Suspension Manager. You register frame, which allows the Suspension Manager to monitor navigation history and to save it. And then, when you are on suspending, you tell the Suspension Manager to save all the data it's been tracking, which is the navigation history, but also, it also actually tracks the state of the page as well. And then on launch, we restore the Suspension Manager, so that brings all that state back again, puts us back to where we were. Silverlight app developers will be aware that the framework does all this for you, but in a Windows Runtime XAML app, you have to actually write this code. This is all plumbed into the more complex templates that use the Suspension Manager. Then let's have a look at image page. This is wired up to use the navigation helper. And navigation helper, we have this standard plumbing code here. And in our onNavigated2, we wire that up. We call the navigation helper onNavigated2, and on our page onNavigatedFrom method, we call the navigation helper.onNavigatedFrom. That's the plumbing, if you like, for working with the navigation helper. But then the navigation helper throws up these two. These are navigation helper events that are fired, both on save state. So when we're leaving the page, we can save whether we're currently in a view model is saying we're in an editing state, and also whether the view model has stored if we're halfway through entering some text. So it saves that into the state dictionary for this page. And then when we come back into this page, if we're recovering from a terminated state, then we will go into our page state dictionary and restore that stuff again. So let's run this again with all this in place. And go into here again, let all that run, and edit it. A name, halfway through, we're going to terminate it. So it should have gone, it's not gone though. Oh, we're on a breakpoint, sorry. So that's saving the stuff away. There we go. And then we can restart it again. And it's going to come in and load the state again, and the result will be we're back exactly where we were. So I haven't got, unfortunately, it's a complex subject, but these are the navigation helper and the Suspension Manager help you to manage these situations by saving and restoring transient state in load state and save state on the page, and just by calling the Suspension Manager .saveAsync and Suspension Manager.loadAsync on suspending and on launched respectively, then you'll get the page history back as well, and all this magic will work. So there's a number of other topics that relate to the application lifecycle that we're going to be covering. Notifications, which is tomorrow, session. Oh, it says 10. Oh, no, that's wrong. It's 14. Switch them around. We changed the agenda. Session 14 is Tiles, Badges, Toast, and Action Center. Sharing files and data is 10. Background working is still 11. That's happening tomorrow. And if you want to know about the application lifecycle in Silverlight apps, then there's an awesome session from the last Jumpstart, which takes you through all of that. So I was going to talk for about 10 minutes or so on localization and globalization in Windows Runtime apps. This is the last session of the ones that are specifically focused on writing Windows Runtime XAML apps. So after we finish this one, then we're into the whole set of APIs that are available, whether you're coding in Silverlight or you're coding in Windows Runtime XAML. So this is the last one that's specific to this particular flavor of the XAML frameworks. So what we're going to do is talk about global market opportunity, developing a localized app, globalization, and translation. So why do you want to do this? Well, a stupid question, really. Why would you want to globalize and localize your apps? Well, like the store is global, that's a good start. 191 markets. We've got support for 54 languages in Windows Phone 8.1. There were 50 in Windows Phone 8.0, and in 8.1 we add an additional 4. And then we also need to think about the languages that your app is offered in. If you offer your app only in English, that's only going to cover around 25% of Windows Phone users. These stats are actually from the middle of 2013, so that might not be completely accurate, but it's give you an indication. So if you add Mandarin and Spanish, that's going to increase your language coverage to around 60%. And if you go the whole hog and add Russian, Italian, Portuguese, and French, you're going to get the majority of all Windows Phone users. But also, you could actually create an app that maybe doesn't do as well as you'd like in some markets, but you could be right up there at the top and really get real good success in other languages if you take the trouble to localize to their language and their currency symbols and date formats, all that kind of good stuff. So the top 15 highest grossest apps in the past, we typically support 8 languages. Also, if you think about the priority markets that you want to offer in, 12 of the top 15 apps are published in 187 or more markets. And China and Latin America download twice as many apps as the US. So, think about the markets you want to localize to, and maybe, it's going to pay off for you to localize. We got some new stuff in, there's a big difference now in the Windows Phone 8.1 devices. So, all 54 of the supported languages, UI languages, will be pre-installed on most phones. There's a difference the way users can handle phones. You can enable multiple languages and sort them by order of preference, and you can continue to auto-download language packs and things for text-to-speech, text prediction, and speech files to align with the selected languages that you pick. This is different from Windows Phone 8, where phones were shipped in kind of regional blocks, if you like. So you kind of have a Latin American phone and a European phone and a North American phone, this sort of thing. So you'd have certain languages would be included in, but not the whole lot. Whereas now any phone can download can use any of the languages. And to support that, obviously in the emulator we've got a lot of there's a whole control panel thing that helps you to support that. Oh my goodness, it doesn't like that clicking. Oh, come back to me. Right, let's try that again. Click, breathe. Got a twitchy emulator here. Right, okay, we're good. Settings, relaxing. Okay. So, scrolling down, there's a lot of settings these days. Shout if you see it.
Language,
thank you so much, yes. So, here we go. We got English, United States. If we want to add language, we can add a language. Let's add Deutschland, there you go. German, we'll add that one on. It needs you to restart the phone, so we can restart the emulator, and it says see you later, and then it reboots and we come up in German. And any of those 54 can be selected like that, and you end up with a list. This is always challenging. I have to carefully pick the language I select, because then what happens is, not for resale, you cannot sell this emulator. There's a funny thing. Go to settings, and then oh gosh, what is settings? You see my problem. Yeah, well, anyway, you get the idea. Yeah, you get the idea. So let's just kill that so I can get one coming back in English. I apologise for my lack of German there. So you kind of get the idea of that. So how do you go about developing a localized app? So first of all, you need to determine which languages you want to support. So the way that you specify languages is by using something called a BCP47 language tag. So you specify, languages can be specified both as a kind of a regional language, such as EN, which means English, and then as well as regional variants. So we have EN-US, and the convention is to have lowercase the first bit and then uppercase the second, which is US English. And then the next one is Queen's English, ENGB, and EN Hong Kong, for example. So you've got these different variants in there. So you can provide resources in any one of those different languages, and then at runtime, Windows takes care of looking at the resources that you've built into your app, looking at the language preferences that the user has selected in the control panel settings, and coming up with the best fit. So it will come up with the best fit for it. So what you need to do is create separate string resources for each, starting with string resources for each locale, each BCP47 code that you want to support. You see in that graphic there, we've got strings for ARSA, DEDE, NUS, and JAJP. But here's the good thing. In the same way as with the images that Matthias showed you, where you don't need to do anything particularly fancy to go and pull a image at the right scale, in a similar way, you don't need to do very much about loading resources. So all you need to do from XAML is specify an x:/UID attribute with and what you put in that word greeting that you see there, that's kind of a key into the resources file. And then the text is blank in the XAML, but then it goes to the resource file and it will go and set on that text block. The text property will be set to bonjour if it's a French phone, if it's the phone is set to the French language, and the width of that will be set to 20. So you can actually set any number of properties from the resource file just by using that x:/UID as a key into the resource file. And then you use the key, greeting, dot, and then whatever property you want to set on that. And in code, you can do things as well. So you can have like that farewell, au revoir there. In code, you can create a new instance of a resource loader and then call loader.getString and again pass the key into the resource file. And the Windows will just take care of going into the resource file and picking the right one out according to whichever resources as selected to match the best fit for the user's selected language preference in the control panel. You can also localize files in the manifest. So there's lots of information in the manifest, such as the display name, description, and things that end up in the store app. And the display name is what you see in the programs list on the phone. So in there, all you need to do is put ms-resource : and then what follows it, app display name in this case, again is the key into the resource file. So nice and easy. And all of this is all part of this the resource loading that we saw with the images. The resource loading that we saw with the images, you can see there we've got logo.scale180, logo.scale240.png. This is what Matthias was talking about for scaling the scale of images. But you can also have locale dependent images as well. So you can also work these whole things together. You can have an images EN-US logo.scale180.png, and to load that in your XAML, you just put /images/logo.png, and Windows will take care of figuring out what scale how to get the scale one and what language one to load. So it's all magic. It makes it really, really easy. So it's just a case of naming things right and putting them in the right folders. Right, a little bit of help with translation, which is the Multilingual App Toolkit, which is an easy-to-use localization tool for, well, it says the Windows Phone SDK, but for the Windows SDK and loads of other SDKs as well. So great integration into it and really makes it easy to translate stuff. So I'm going to do a little demo for that. So here I'm going to go to the begin first, and then I'll quickly switch to the end one, just so that we can. I've got my it's our old friend, the Contoso Cookbook, yay! And the About page, for example, has got a bunch of fields in here, and I've got these magic XUIDs I've added: app name, About page header, version text, all this sort of thing. So all the text that you're seeing on there, sure, in design time we're seeing the English version, and of course I've got a resource file with just the US at the moment, which has got the US English versions for them. And then I can do, I've got into tools and extensions and updates, I've installed the tools, the multilingual app toolkit. So you can just go along, you can go online and install this yourself. You can go and find it and then install it. I've installed it. So then, because I've lost my notes, so I'm just going to guess on this. Where do we do that? Let me just find my notes here so I can figure out, remember how to do this. Apologies. Okay. So somewhere in these things up here, there's a way of enabling the multilingual toolkit. Somebody tell me where this is. Project. On the tools menu. I couldn't see it before.
No, I didn't. Preemptive.
Oh, that's weird. It's not there. Maybe I need to build. No, that's okay. So I've got a glitch here. So there should be on the tools menu a enable multilingual toolkit, and it ain't there. So that's a bit confusing. Oh, disappointing. So I will try one thing and then we'll just leave it, which is it's probably an update. It's probably, no, that's CSS stuff. So installed tools, uninstall and put it back in again. Which it won't allow me to. All right, well, this is officially today's demo that bombed. All right, I'm struggling to. Maybe it doesn't like it. That's kind of weird. Let me open the finished one. Hopefully it will still be working. It will actually work in the finished one. Because like all good professionals, I never leave myself open to chance here. So. The multilingual stuff is in here. I can try and open it. No, it's definitely broken.
So there is a great demo, if we can't pull it up here, on Channel 9 inside Windows Phone on the Multilingual App Toolkit, 20-30 minutes, if anybody's interested in going to check it out.
Oh, I got it.
There we go.
I got it, yes, there we go. This is the Multilingual App Toolkit where you can translate to different things. So I can, see, all my context menus are not here. This is a bit disappointing. You mentioned it's very easy to add languages. Trust me, guys, it's really easy to add languages. This is some of the hazards of working with not quite final release software. All right, well, we'll move on. It does honestly make it really easy to handle translations. Yeah. Let's look at the French one, open with the multilingual editor. You can see this is the translation and all of the different values in here. But the real cool thing about this is that you can automatically translate against Bing in order to get suggested translations really easily. So yeah, we'll blog about this, point you to.
And I think a fun thing about that is that it uses like you said, the Bing Translate for free. Normally, Bing Translate is a paid service, but if you're using it to translate your Windows Phone application using the Multilingual App Toolkit, it's a free service. You can do as many translations as you want to as many languages as you want.
Yep. No, it really doesn't want to play. Okay, we'll move on. there are some good assets for helping you translate stuff, particularly where you've got technical terms, you know. So this terminology lookup, which is this language portal, is really, really useful. You can search and enter an English term or another language and then select a language to translate it for. So things like Windows terminology is really easy for that. You can also download the UI strings if you've got an MSDN subscription. The UI strings glossary is a great cross-reference for the standard strings in a computer UI that you can use. Now, finally, on globalization, there's a whole bunch of APIs that can help you with other stuff as well, like globalization.calendar to get time zones and work with time zones, and date time formatting. So it's really important with this, kind of think about these things as well, formatting dates and times appropriately. Formatting numbers and currencies. So there's the number formatting class as well for doing good, appropriate local, regional formatting for numbers and currencies. All these little things all add up to making a truly world-ready app. And calendars as well. The windows.globalization.calendar class allows you to work directly on calendar dates and gives you appropriate representations for different regions and cultures. And that, with our unspectacular demo, is the end of that particular module. So that is also the end of the little mini course of the Windows Runtime XAML. So we're just going to dive down into cool stuff like files, yay, and stuff like that in the next session. So we'll be back in a few minutes. How many? 10 minutes. We're getting the call from the back of the room. Right. So 10 minutes. We'll see you in 10. Thanks a lot.